Math 102, example 3.4.2. So let's do another example of finding all the zeros. Now here, this one is degree 4, so this is going to have 4 zeros. So let's do that whole P and Q thing. So again, P is a factor of the constant term. Here is 2, so 1 and 2. Q is a factor of my leading coefficient 6, so 1, 2, 3, and 6. So to get the P over Q, I put all the P's over all the Q's. So let's put both of the P's over 1. Let's put both of the P's over 2. And as I make my list, I do get repeats, which I will cross out. Let's put all the P's over 3. And then let's put all the P's over 6. And there's another repeat. So again, that is a list of all the rational numbers that might work in this function. It's quite a lengthy list, and I'm a bad guesser. So again, let's use my calculator to help. So there's the function. Let's get the graph. All right, well, looking at that graph, I would say -2 looks like a pretty good number to start with. That looks like it will work. So -2, and let's plug it in and see what we get. 6 times -2 is -12, plus 7 is -5, times -2 is 10, plus -12 is -2, times -2 is 4, plus -3 is 1, times -2 is -2, and there is the remainder of 0 I was expecting to get. Now, this quotient, though, this is a cubic. We haven't really discussed how to solve a cubic. So what that means is I need to continue to guess and check with my numbers and my calculator picture. All right, so again, I look at my picture, I pick -2. So coming along here to the left, I do have something between -1 and 0, and I've got a couple possibilities that might work. So let's try picking -1/2. Now, as I guess, I'm not going to use the original polynomial. I'm going to use the quotient that I just got from my previous 0. And let's see what we get. 6 times -1/2 is -3, plus 5 is -8, times -1/2 is 4, plus -2 is 2, times -1/2 is -1. So I do get a remainder of 0. So it looks like I did guess that correctly. And again, this is now a quadratic. So here's my A, my B. So here's my A, B, and C, and I can go ahead and use the quadratic formula. So -b plus or minus the square root of b squared minus 4 times A times C, all over 2 times A. So I get 8 plus or minus the square root of 64 minus, it's 24 times 2 is 48, all over 12. And let me continue this up here since I'm running out of room. So when I subtract, there's my pencil again, I get 16, and the square root of 16 is 4. Once again, when I get a perfect square, I'm going to write it as 2 quantities, one with the plus and one with the minus, just to see my arithmetic more easily. 8 plus 12 is 20, and 20 over 12, that reduces to 5/3. 8 minus 12 is -4, and -4 over 12 is -1/3. So here, now again, those fractions are a little bit harder to see graphically, but if we look at the graph, it does hopefully look like, at least vaguely, that we have ones in that area. So here, my zeros are -2, negative 1/2, come on, negative 1/3, and 5/3. There's 5 zeros, so we are done.